Good morning. So we'll start session 6 on chapter Is Matter Around Us Here. So in our previous class we understood how to separate the various components of mixture. We also listed down the different methods such as bifunnel method, sublimation, centrifugation, distillation, chromatography methods, etc. Right? And we discussed the first two methods, that is by how to separate the volatile component from a non-volatile component. Volatile component was nothing but water. Non-volatile component what we used was a dye, that is blue-black ink. How did we took out the dye from that, which is nothing but dye is a combination of or a blue-black ink is a combination of a dye and water, right? And we also understood about centrifugation method. How do we use or how do we get the cream from the buttermilk by churning? So centrifugation also works on the same principle. I also told you, please observe when your washing machine is spinning, it will give you the best example for centrifugation, right? Now we'll move on to the next method, that is funnel method. Now funnel method, when we talk about, it is very simple. You might think just use a funnel and then use the substance. Yes. But here, what type of liquids or what type of components we separate in funnel method is, we use this to separate two immiscible liquids. Now what are immiscible liquids? Liquids that do not get mixed with each other. For example, oil and water are liquids but they do not mix with each other. That is why such liquids which do not intermix with each other are called as immiscible liquids. Then what are miscible liquids? Which can intermix or which can mix with each other. If I take milk and water, I can mix with each other. Those come under miscible liquids. So this is immiscible liquids. We separate two immiscible liquids by funnel method. So this is the pictorial representation how a funnel method actually it will be. So this is the separating funnel. So these are the two immiscible liquids, kerosene oil and water, right? So this has a knob or a valve. Now what basically we do here is, we tighten the ball, we add water, kerosene, which is actually not mixed, but the combination of this immiscible liquid we add in this funnel. Allow it to settle down without disturbing it for some time. After some time, what you see? Naturally, oil will float on water. Why? Its density is less than that of water. Oil always floats. Not only on this, when we cook food, when we add some oil to it, you always see the oil floating on it. The more oil you add, the more amount of oil it floats. Sometimes we even just take it out from a spoon and throw, right? So here what happens in larger quantity when we do this, we do not disturb that, allow it to settle for some time. After some time, we see that kerosene is obtained or kerosene is just floating on this and it is only water below, right? Slowly we take a beaker and we slowly loosen the knob of the funnel. Once you loosen the knob of the funnel, very slowly only the water gets collected into this. Once the water gets collected, it is only left with kerosene. Now it is not that very simple as I am telling here is, you can also tell, even sometimes the oil get mixed into it. No, it will not, because it is done separation in that very, this knob is left open in a very, the valve opens slowly, so that only amount of water can flow into it and there it actually stops. Now here, this funnel method, it is just given an example for kerosene oil and water. But actually, funnel method is used in industries where we extract the iron from iron ore, that you study in your 10th standard, extraction of the different metals from its ores. So when we extract iron from iron ore, some molten slag is left behind. Now what is this slag? Impurities, right? So that impurities are always light. So that will actually stay here. Molten iron will actually settle down. That means what we do here is we extract all the molten iron and the slag is left behind. This funnel method principle is actually used in extraction of iron from its ore. This is funnel method, or if the question is asked, give an experiment how to separate two immiscible liquids. You can go with this method. Now we'll go on to the next method, that is sublimation. We all know what is sublimation. What is sublimation? The process where the substance directly changes from solid to gases. We studied in the first chapter, matter in our surroundings, how the substances will change on heating. Solid to liquid and then to gases. Correct? But in sublimation, what will happen? The solid will directly turn to gases on heating. That is called as sublimation. Example, naphthalene balls, camphor. Camphor and naphthalene, even at the room temperature when you keep, they suddenly disappear, what we can say. That means they have changed from solid to gases on heating. So here, sublimation method is used to separate volatile component from a non-volatile component. Now that means, why the word sublimation? We can also give the first experiment which we have done, correct? But here the volatile component is sublimable and the non-volatile component is non-sublimable. That is different. But there our volatile component was what? Water. We had to heat the water so that it will evaporate. But that was not sublimable. Here the component what we use is sublimable. The question can be given experiment to explain how to separate the volatile component from a non-volatile component. This is not the experiment. It is the separating the dye from the ink. Give an experiment to explain to separate volatile component which is sublimable from a non-volatile component. Sublimation is the method. Do not get confused because we use the sublimable material in the given experiment. Yes. So what is our aim? Our aim is to separate ammonium chloride, which is sublimable, which is mixed with salt. Yes. To separate ammonium chloride and salt by sublimation. That means I have salt mixed with ammonium chloride. Instead of ammonium chloride, camphor also can be used here with salt. So this is how the experiment looks like. We have a simple funnel, right? We put the funnel, we put it inverted on a china dish. China dish is a type of a dish which we use in our chemistry lab. So it is basically this way in shape. So this is called as a china dish. Basically, which is funnels which we use in our lab. We just put that inverted and we put a cotton plug here. What is cotton plug? It can be a small cork or it can be a cotton. Just fix it in it so that air or gases do not pass out through the funnel, right? As I had told you, we use typical names in chemistry sometimes. I just cannot write here cotton. I have to either use the word a small rubber cork or a cotton plug. Now this is not a plate or a bowl. It is called as a china dish only. Like remember last time we said watch glass. Yes. So typical those chemistry lab equipments what we use, we have to name them correctly. So we use a china dish. On china dish we just put an inverted funnel. Then we heat. What we keep in the china dish? In the china dish I take a mixture of ammonium chloride and salt, right? On that I invert the funnel. Then I put a cotton plug on the funnel and start heating it. Once I start heating it, what will happen? So ammonium chloride, which is sublimable, will start evaporating from solid to gases directly. But that gases cannot escape out because we have fixed a cotton plug there. So what will happen? Once we see that it starts evaporating and at a point it will stop, we will stop heating it. Once we stop heating it, that means we are allowing it to cool. Now, if we are allowing it to cool, that means what process we are doing it? Condensation. Now, what is condensation? It is the opposite of sublimation. Sublimation, solid will change to gases directly. Condensation, what will happen? gases will change to solid again, right? Where it will not turn to liquid, that is condensation. So these vapors, when they pass and we stop heating it and allow it to cool, what will happen? Ammonium chloride will again come and settle on the funnel. It will just be on the outer, in the surface of the funnel here. It will deposit there, what you can see. What remained in the china dish? Only salt remained in the china dish. Our aim was to separate ammonium chloride and salt, and that is what we have done. It's a very slow process. It can be done in your laboratory. If not ammonium chloride, you can also try this with camphor. So this is the process of sublimation, where we separate the volatile component from, which is sublimable, from a non-volatile component. So today we understood two methods. One is funnel method of separating two immiscible liquids, and a volatile component from a non-volatile, which is sublimable. So in our next classes, we will again start with new different methods where we can separate the components of mixture. In today's class, if you have any doubt, you can call on the same day of the video set.